Hi everyone. So this program is kind of similar, well, actually it's very similar to LAB24 in chapter 5, I believe, in the Xi book. And in that lab, you're being asked to use a vector to store people's weight. So I did a twist on that lab just for people who need guidance with that lab. And this one is dealing with calories for like ice cream flavors, say. So I'm going to walk you through this so you have have a plan of action for that other lab. So let me run this program, and I am going to enter the calories for five flavors of ice cream. So let's say the first flavor has 250 calories, second flavor has 300 calories per serving, the third flavor has 350, fourth flavor, say 200, fifth flavor, let's say it's like a light version and it has 180 calories per serving. So then we have, here are the calories you entered. I'm just kind of running that back to the user, showing them the list of calories, and then getting a grand total. So let's say they wanted to eat all 5 flavors. They would be eating over 2,000 or 1,200 calories worth of ice cream. And then we have the average, which I've computed, and then also the highest calorie flavor, which was 350. So I'll show you how I did all of that. Starting at the top here, it's important in the lab, when you do the lab, that you include vector up at the top. And there is a note in the Xi book that you need to include that. The other two are already provided. Okay, the IO manip is there because we are using set precision in this program. So I'm creating a vector. I did it of type float because we're displaying the calories in like to 2 decimal places. I think you saw that. See, everything is done to 2 decimal places, just like in that lab. So I used a float. You could use a double too, but I just used float. And then I created a vector called calories, and I set it to a size of 5, okay, just like in that lab. And then I have some other variables, and you'll need these as well. So I have the total cals. Now, keep in mind, that lab is not dealing with calories, so don't use cals in your variables. Like, don't copy this and paste it in and expect it to work. It won't, okay? You have to modify for that lab. So anyway, I have total cals. And very importantly, initialize this one to 0. You have to start at a nice clean 0 when you're using, this is called an accumulator variable. I don't know if the Xi book uses that term, but that's called an accumulator because we're getting a cumulative total as we go through the loop and get all the values. So set that to a nice clean 0. And average calories, which you'll compute at the end after you've gotten the grand total or the running total. And then also the max calories, the highest calorie flavor, also set that one when you're doing the max weight for the people. Set that one to 0 as well. That's important. So I have a loop here. I'm actually using 2 loops in this program. I could use 1 loop to accomplish everything, I think, but no, you know what? Maybe I couldn't actually. So definitely two loops in that lab. So the first loop is, I guess we would call like this loop is probably doing most of the heavy lifting, I would say, in the program. We're getting the calories for each flavor from the user. We're populating the vector. Okay, and also we're doing some math operations as we go. So let me just like kind of pick through this loop. So I have my loop header. Very importantly, my loop counter, it doesn't matter what you call this, but you do need to start at 0 so that it corresponds, like the loop counter values, starting at 0, and this loop is going to keep going while the loop counter is less than size. Size is 5 in this case, so we're looking at values of 0 through 4 for loop counter I during the course of this loop. So 0 through 4 correspond to the indexes of the vector, and that's important, very important. You want your loop count, because we're kind of looping through the vector, we want the indexes of the loop counter, or the loop counter values, to correspond to the indexes of the vector, which are 0 through 4 on a vector of size 5. So anyway, that's it. Be careful in setting up your loop header. And so then I would, if you look at the output here, it says enter calories for flavor 1, enter calories for flavor 2, enter calories for flavor 3, and so on. Where are those 1, 2, 3, and so on coming from? They're coming from the loop counter, but remember, the loop counter has values 0 through 4. I don't want to say enter calories for flavor 0. Regular people, our users, start counting at 1. So I'm going to offset by 1 when I'm looping through and saying enter calories for flavor I plus 1 is 1, and so on. When you're in the first time in the loop. So anyway, yeah, so we're offsetting by 1, and that causes that output, that user-friendly 1, 2, 3, and so on. So okay, so we can use cin to get the calories for that flavor, and we're using the at function of the vector to place those calories in that location, using the loop counter to specify that location. So the first time through the loop, I is 0, we're putting the calories, I think I entered 250, into that first location, which has an index of 0. Second time through the loop, I is 1. And so we're putting the calories into that second location, which has an index of 1, and so on. So this allows us to move through the vector and put the calories into the vector. Okay, so as I'm doing, so that's populating the vector, all right? This part here is populating the vector. And while I'm at it, I'm going to get that cumulative total we talked about. So the total cals, which I started at 0 at the top, I'm going to say total cals equals whatever's already in there, okay, plus the new calories that I just put into the vector, okay, the new value that just came in, I'm going to add that to the lump sum. And, you know, this is such a common thing to want to do in coding in general that we have a shortcut for it. And that's what I had. So I'll comment this out and I'll do the shortcut below it. These two statements mean the exact same thing. So this here is the arithmetic assignment operator. All right. So we're getting that running total, or the cumulative total, which we are going to divide at the end to get the average. Okay, and then also in this loop, I'm going to isolate the maximum calories. So recall that we have this max cals variable that I have set to 0. I set it to 0 because you've got to start somewhere, right? And so we're saying if the calories that were just entered are greater than max cals. Okay, so the first time through, they're never going to be 0 calories. So the first one is going to become the max. That becomes like the one to beat. You know what I mean? So if it's greater than the whatever's in max cals at the moment, then the max cals becomes that new high value, that new higher value. Okay, so it's just a quick little logical maneuver here. That allows us to isolate the max value. So again, you know, if the value that was just entered is greater than the current max value, then make that current max value that new value that was just entered. Okay, and then now this new one becomes the one to beat next time through the loop. Okay, so that was really the tough part. Now we're kind of home free. Once I have that, now notice how this is the end of that first loop. Okay, I am going to get an average, right? We would get the average by dividing that running total that we got in the previous loop by the size of the array, okay, or not the array, the vector. I'm so used to arrays, I'm sure I'll slip many times and say array instead of vector. I mean vector in this case. So the size of the vector. And, okay, then we're just turning on the set precision. I'm going to say here are the calories you entered, and then just going to zip through that vector really quickly with just a quick little loop here. I used loop counter Z, again starting at 0. Got to keep going while Z is less than the size of the vector, which takes us indexes 0 through 4, or loop counter values 0 through 4. Everything is lined up. And yeah, so just printing the calories separated by a space, and getting the calories out of the vector and printing them. Okay, we're just zipping through the vector with this quick little loop here, and I'm using the loop counter as the vector index here. All right, and then let's see, now I'm ready to display everything. This is just a big C out at the end. Now I did a little variation on the output just so, you know, I mean, you have to modify it a little bit for the Zybook lab, but this is all basically the same thing. So you can use this code as your guide. You can't copy and paste it and just expect it to work. It's not going to. But if you do just some small modifications, it should not be too difficult for you.